Many applications depend on the interference effects of light. Let's focus on one of these, which is the physics of compact disc and digital video disc, more commonly known as CDs and DVDs. The CD and DVD revolutionized how text, graphics, music, and movies are stored for use in computers, stereo sound systems, and televisions, although they are less used frequently today, since movies and music are commonly live streamed or downloaded from the web. The operation of these discs uses interference effects in some very interesting ways. Each disc contains a spiral track that holds the information, which is detected using a laser beam that reflects from the bottom of the disc, as the figure shows. The information is encoded in the form of raised areas on the bottom of the disc. Under a microscope, these raised areas appear as pits when viewed from the top or labeled side of the disc. They are separated by flat areas called land. The pits and land are covered with a transparent plastic coating, which has been omitted from the drawing for simplicity. As the disc rotates, the laser beam reflects off the bottom and into a detector. The reflected light intensity fluctuates as the pits and land areas pass by, and the fluctuations convey the information as a series of binary numbers, or zeros or ones. This digital information is then converted into what's called an analog signal, which is a fluctuating voltage that can be amplified to drive a speaker, for example, and reveal the sound information stored on the disc. To make the fluctuations easier to detect, the pit thickness T is specifically chosen to take advantage of destructive interference effects. As the laser beam overlaps the edges of a pit, part of the beam is reflected from the raised pit surface and part from the land. The part that reflects from the land travels an additional distance of 2t. The thickness of the pits is chosen so that 2t is 1/2 of a wavelength of the laser beam in the plastic coating. With this difference, destructive interference occurs when the two parts of the reflected beam combine. As a result, there is markedly less reflected intensity when the laser beam passes over a pit edge than when it passes over other places on the surface. Thus, the fluctuations in reflected light that occur while the disc rotates are large enough to detect because of the effects of destructive interference. The pit thickness, and other dimensions as well, are smaller on a DVD because the lasers used for DVDs have smaller wavelengths, 635 nanometers for example. The fact that the pit dimensions are smaller is one of the reasons that a DVD can store more information than a CD can, from 7 to 26 times more, depending on the type of DVD.